Let's talk about frame rate and the concept of ticking in Minecraft. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. If you ever go into the settings of Minecraft graphics section, you will see that you have something called VSync. Also, we are all familiar with the name frame per second, and actually we can see that value in the game. Now here is a question. What is frame? What is frame per second? What is VSync? And at the end, what is ticking? When your graphic card is doing its calculations to draw an image in front of the monitor, it is called a frame. So the final result of that calculation will be a solid non-animated image that you see in front of the monitor, and that is called a frame. Depending on your graphic card and your hardware on your computer, the number of times your system can calculate images will differ. For example, if I open a single specific world on my computer, my hardware and graphic card may be able to draw 30 images each second. And if you open the same world, same file on your own computer, your hardware and your graphic card may be able to draw 80 images per second. This is called frame per second. It means that each hardware can draw a specific number of images in each second. So when you see that your game is showing 20 frames per second, it means that each second that hardware is calculating and drawing 20 images one after another. If your game is showing 120 frames per second, well, guess what? You are calculating and drawing 120 images each second. Now, what is a VSync? VSync is the number of frames that your monitor can show. Some hardwares in some monitors make them so that they can show up to 60 images each second, or maybe 100 images each second. No matter how fast your game is being rendered and showed, your monitor can't catch up to it, And turning on VSync in the game settings means that, hey, don't bother yourself with more calculations. If my monitor can only handle 30 images each second, don't bother yourself drawing 120 images. Just do 30 per second because I can't see more than that. That's the meaning of VSync. Now, in game engines like Unity 3D, we have few different concepts that may help us understand this process easier. We have update. The update method will happen each frame. Means that each time your computer will try to draw a frame, it will call the update method, and the update method will do its job. Then we have late update. In Unity 3D, late update is a method that will happen at the end of the update time, right before when the camera is trying to show the image to the player. So, for example, if you want to adjust your camera position, you will not do it in update, but you will do it in late update, because late update is dedicated to cameras in Unity 3D. However, we have something called fixed update. Now, understanding fixed update will make you understand ticks in Minecraft. No matter how many times you can draw an image per second, fixed update will be called a certain amount of times in each second. For example, fixed update in Unity is 50. So even if you have a game that runs 200 frames per second, meaning that you will have 200 times calling the update and late update, but the fixed update will only happen 50 times. If you have a system that will go down to 30 frames per second, again, the computer will try to call a fixed update 50 times a second. It may not succeed because now you are lacking behind. But if you can update faster, it doesn't matter. You will only call the fixed update certain amount of times per second. Now, in Minecraft, we have ticks. Ticks is equivalent of fixed update in Unity Engine. It means that no matter how fast your frame per second is, no matter if you turned on VSync or is it turned off, no matter how good your optimization mod is, maybe you have sodium, you may have lithium, and your frame rates can be, 200, 300, 120, it doesn't matter. The tick logic will happen only 20 times each second. Means that 20 ticks equals to 1 second in game engine. So when you have a block entity, one of the main differences between a block entity and a block, other than being instantiable and stuff like that, is that a block entity can tick. It may not, but it can. So So if you add a tick method to block entity and register it as the ticker, that block entity will call the tick method 20 times each second. And the process that you add to that tick logic inside the tick method will be calculated 20 times per second per instance of block entity. This is critical. If you don't understand this, you may add a very complex logic inside the block entity's tick method. And for example, you may have 6,000 lines. That's an example. Don't argue with me. That's an extreme impossible example. If you have 6,000 lines of complex mathematical code sitting inside tick method, this will be called 20 times per second. So each second you will have 20 multiplied 6,000 means that you have 120,000 lines of mathematical code calculation for one instance of that block entity. Now, let's say that a game server has, I don't know, 100 players. And from these 100 players, at any time in the day, we have 20 players online, okay? Each player, let's say that they have 5 instances of that block entity for themselves. Multiply it by 20 players, multiply it by 120,000. It means 12 million lines of code happening each second. Can you imagine how laggy this server will be? I would say that if it's a heavy math calculation, that server will come to a screeching halt with 1 or 2 or 3 frames per second, nothing above that. And each player would think to himself, hey, I only have 5 of this block. Why is it lagging so much? So if you are adding a block entity code, make sure that whatever code you are writing in tick method is as optimized as possible. Also, thinking about Minecraft game, normally you wouldn't have a very complex logic inside your tick method. The most complex logic would be for machines that are crafting something, using energy and fluid, and I don't know, maybe something else, just to produce something. And this is the most complex logic that you will have in a tick method. Even if you have a very complex way of handling it, like a behavior tree, that logic wouldn't pass maybe 200 lines of code, and most of it is not mathematical things, so it will be very fast. And that is critical to understand, because if we agree that each second is 1,000 milliseconds or 1 million nanoseconds. If we say that our code would run in 5 milliseconds, okay? So we have to divide it by 1,000 to get the millisecond. We have to divide it by 20 to get 1 tick time. Let's say that we have exactly 50 milliseconds to tick a block entity to get 1 second pass. Now, if our code is taking 60 milliseconds, this is bad because it will drop. Our best choice is to have that tick logic happen in less than 50 milliseconds. Normally, it would be 50 nanoseconds, or I don't know, 1 millisecond, 5 milliseconds, nothing above that. That's okay. Think about it. This is the tick time for the server. So I didn't look into the Minecraft code and dive enough into the code to see how the multi-threading is working, or if it even has a multi-threading concept or not. But if we think about a block entity that would get 20 milliseconds to tick one instance of itself, it means that the whole server may not handle more than 3 instances of that block entity properly. So your best bet is to have a code that its tick method would run less than 1 millisecond, and in some cases less than, I don't know, maybe 20 nanoseconds, because we don't want to go above that and let the server has its time to deal with other instances of that block entity or any other block entity that it has, just to be able to have a decent frame rate and a fast game without hiccups. Normally, we don't track this runtime for tick methods. If you want to, you can benchmark it. And by benchmark, if you don't know what it means that we will track the amount of time we passed inside one method. For example, at the start of the constructor, here, I will log the time, okay? And at the end of it, I will log the time again. So in the console, I will get something like this. I don't know, maybe it's 12 o'clock, 30 minutes, 10 seconds, and 500 milliseconds. And at the end of the method, I will see the same thing. It means that this code ran in less than 1 millisecond. That is when you want to benchmark the nanosecond. But sometimes you see this. It means that this particular method took 30 milliseconds to execute. And getting these log times and comparing the start to the end means benchmarking. Sometimes you don't log the start. So you add the start to some variable And at the end of the method, you add the end to some variable, and then you log the end minus the start. This is, again, a benchmarking. And assigning these two values and that minus operation is really fast. It's 1 nanosecond maybe, so it's not worth tracking that little code. And this is benchmarking. As I said, normally we don't benchmark our methods inside Minecraft. If you ever find that your game is really bothering you when you put a special block entity inside the game, you see a huge drop on the frame rates per second. Means that you need to track its tick method, and maybe you want to benchmark the execution time on tick method. How you will benchmark that? It's up to you. You may add something in the GUI, you may just print some logs. It's up to you, you know. But you need to somehow track the execution time of that method to see if that tick method is responsible or not. As I said, normally we don't do this. However, what we really need to keep an eye onto is the frames per second. If our tick logic takes long, it means that the computer wouldn't be able to draw an image as fast as it should be. It will take longer time to calculate the final image to show, and the frame rate will drop. Your FPS, frame per second, will drop. Normally, if your FPS is around 60 to 70 and you put a single block entity on the board and you suddenly see that your frame rate dropped to 20 to 30 and it's remaining there, so it's not spiking down and then coming back up, it's still 20 to 30 frames per second, then it means that something is wrong with that block entity. Stop right there, look at the textures, maybe it's animated and has interpolations that should not. Maybe your tick logic is complex, maybe something else is going on that you are not aware of. For example, I remember that a few years ago, Ender.io would draw the redstone pipe in such a way that it would flash on and off with each redstone pulse. The code looked optimized enough. Someday, a player that has a YouTube channel was talking with other players on a server and said that this server became so laggy. It wasn't like this at the start. It wasn't like this at the first few months, but now it's really laggy and we can't play correctly. The nice thing was that that server was for the mod developers. They were testing their own mods around the server. Each mod developer started tracking their own mod. And before each developer started tracking their own mod, there was a tool that the server admin used and identified the chunks that was causing the massive spikes in the calculation time and droppage of the frame rate. And after identifying those chunks, players / developers sit back and dive through everything that was in that chunk. At the end, they identified the problem. Guess what? It was Ender.io's redstone pipes. Now, the tick logic was really simple. It couldn't cause the problem. So the server shouldn't lag, but the clients were lagging a lot. And the reason was the pipes rendering. It was constantly rendering two different models, on, off, on, off. And the funny part was that at the time we didn't have JSON models for the blocks. We were using coding to have special block types, and Render.io's cables was exactly one of those cases that you had to use code. And because he had to do custom rendering, it was causing a lot of lag. So until they fixed it, the players had to add a new channel to the pipe and assign it to a lever, keep the lever on so that the pipe would render as turned on all the time. And that would fix the lag. Of course, the pipes wouldn't look nice, but that would fix the lag. And honestly, this is a good example, although it's not related to tick method, but in general, it shows you that you need to be careful about things that would happen a lot of time in the game. For example, let's say that you will have an alloy furnace, okay? Now, normally each player would have only one alloy furnace, maybe two alloy furnaces, nothing beyond that. And having 10 players on the server means that we will have up to 20 alloy furnaces. And alloy furnaces are not busy all the time, so that's okay. But in case of something like a cable, well, a single player can have up to 200 blocks of cables around the game. And that means 200 instances of the block entity. And I'm not even exaggerating. I think I even gave you the smallest number of cables in the game, okay? Now think about your tick logic in a cable. If it's really complex, then it means that the cable will cause problems for Minecraft in the tick method. Now you may say that, okay, I only have one type of cable and it's responsible of spreading energy and moving energy around. It's not a big deal. No, it's not a big deal. It's really small actually, and it's okay. But then when you put that cable in the board, you see that it's lagging. And you would think that, hey, why do I lag a lot? Remember, we are not dealing with it right now, but I want you to remember it. The rendering, the custom rendering of anything by code is one of those bottlenecks that you should be aware of and keep track of. Now, after all of this, finally we understand that we have ticks that can happen in a block entity. Now, can a block entity have no ticks? Yes. A chest, for example, may have an inventory, and this inventory will not tick. It's a block entity with an inventory, but it will not tick. Now, here is a very critical question. Can we have, let's say, a block inside the game that is not associated to a block entity, but has some special functionality? Yes, we can, and I think we have few of them inside Minecraft vanilla code. Most of them has interfaces, and the interface is responsible of handling the functionality. So they may not have a block entity associated to them, but they have screens and the screen handlers, and the logic is happening inside the screen itself and not the block entity. What about these things? These will not tick. Normally, the game engine will handle the interfaces itself. So we don't need to deal with the ticking of a user interface. Now, in my library, you may see that I have a tick client code. For example, right now you see that I have a tick and a tick client. Normally, you don't have to do anything with this guy. And maybe in future versions, I make it so that it has a default empty body so that you don't need to override it over and over. Because if I comment it right now, you see that I get an error. It says implement methods. I will fix that between the videos, maybe in future. But the thing is that the tick, this is one thing that you need to keep in mind. The tick method normally will happen server side because it's all about logic, and you don't draw things inside tick method in a block entity. The block entity tick method is all about calculating logical comparisons and handling some variables on the block entity, and that's it. And all of these need to happen on server side. Because of that, when you follow some video tutorials on the YouTube that is all over the place, you normally see that people check if the tick is happening on the server side. For example, you will see that they have some code like this. If word.is client, then return. This means that, hey, we don't want to call the tick on the client side. Of course, I don't have the words right here, but if I go with properties.word is client, this will happen, this will work. And this means that, hey, don't handle the tick on client side. The way Turtiworty had wrote his code, and I followed his example and used the same code. If we go into the rabbit hole of our library and look at the block entity, I think it's not here, sorry, it's in the base. And interfaces, I tick, you see that the create ticker will ask if we are not client side, if we are on the server side, then call the tick. Now, normally at this section, Turtiworty or anyone else will return null, means that they don't want to tick client side. However, I don't know who will use my library and how they will use this library, so I added the tick client. As a normal mod developer, you don't have to do anything with the tick client because all the logic will happen on the tick. Now, remember, this library is more complex compared to what I showed you right now. There is a lot going on behind the scenes. I will have videos about them, and right now we are moving in parallel to them to understand the base concepts of mod developing. However, if you want the vanilla way of adding tick method to any block entity, you can hit shift twice and search for abstract furnace and include non-projects, open the abstract furnace block entity and then abstract furnace block. Now on abstract furnace block entity, you see this tick method. Notice that it's public and static. These two are really important. It should remain public, it should remain static. And it's called tick that accepts a word, position, state, and a block entity. Now on abstract furnace block, you see that they added a protected static with some generics validate ticker. And inside validate ticker, they are using the abstract furnace block entity.tick. Basically, here is where they are adding their own tick method on top of the block. Now, take note that the abstract fairness block is extending block with entity. If we go there, we see that we again have a validate ticker here. And honestly, somewhere in these codes, you should see the get ticker. However, I didn't see it here. And abstract fairness block, I didn't see that get ticker here. And that makes sense because these are abstract classes. And whenever you are extending them, you will handle that ticker yourself. For example, if I go for fairness block, you will see that get ticker here, and they are calling their own validate ticker, sending a word type, and then block entity type. Okay, and this validate ticker will come into abstract fairness block, call this validate ticker. Now, as you see, it's calling this validate ticker. This is sitting on block with entity. So somehow it's calling it super and assign a function there. Okay. And again, you can use this validate ticker if you want. You can use the one inside the abstract fairness. This is how you will assign a ticker to a block entity. And it boils down to this central line. However, the way Turtiworthy had done his code and I got it and added to my library, it means that now we can easily go back. If I want to show you what we have here inside my abstract class and inside get ticker, we don't need to do any of that. We just say, hey, if our block entity is instance of our own interface, iTick, then we just create the ticker. And this create ticker is exactly what I showed you at the start. If we are not an instance of ourselves, then please go with vanilla way. And the vanilla way is just this, return validate ticker, blah, blah, blah. And here I just call the super. So I don't do anything special here, but if you want to, you can use that validate ticker, and the validate ticker code is just below it. So it's protected. And this is the super one. It comes from block with entity. So I'm not using the one related to the fairness. Honestly, in my own mods, I will just implement iTick. For example, if you look at the GUI, it's tickable BE. Tickable BE is implementing iTick. That's it. This implementation of iTick means that I have to override tick and tick client. Of course, it's much easier compared to what you think, because now we have on internal tick is here down, and it says, hey, if the tick logic is not null, call the tick method on tick logic. And if you notice, we have this tick logic and the tick method. As I said, it's more complex compared to what vanilla is doing. It's much more flexible compared to that. In the next video, we will tell you, of course, that you have to write your own class that implements iTick logic, and then write your logic inside the tick, assign it to the properties, and that's it. The whole system will work, because behind the scenes, I'm assigning the tick logic from that iTickable BE to the system. So I'm assigning this tick logic somewhere in my library, and it will work. And we will see that in action actually in the next video. And this way I got you rid of all the necessities of having a public static method inside your block entity. Although you may argue that now you have a class. For time being, yes, this can be a class. This can become a lambda here. So instead of tick logic, I may want to assign a lambda here and say, go to something and, just add my own code internally, but that doesn't make sense. Actually, you can't do that, but whatever. The way I did it opens the door for a much more complex and flexible thing in future that will be implemented in my library whenever I have time to sit back and write the tick logic library. And at that time, you would come face to face with a modern way of writing artificial intelligence for any game, but dedicatedly fabricated for Minecraft. Anyways, now that we understood the tick and tick logic and the necessities for ticking the block entity and what we should keep in mind, in the next video, we will come back and I will talk about the changes that happened inside the base GUI block, because we need to understand that one first, and what happened inside the GUI block itself, maybe for 5 minutes, and then we will start writing our tick logic for the air GUI bound. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.